Please now welcome Rob Holt, Allen Vercoe, and Anita Mitchell Isler, who will introduce us to work package number 6, which is entitled Targeting the Microbiome to Improve Outcomes for Colorectal Cancer. Professor Holt is a fellow Canadian who completed his PhD in pharmacology at the University of Alberta. Since 2003, Rob has been a scientist at Canada's Michael Smith Genome Science Centre at the British Columbia Cancer Agency, where he is also co-director of the immunotherapy program. Emma is a professor and Canada Research Chair in the Department of Molecular and Cellular Biology at the University of Guelph. Another very profiled Canadian, I might add. In 2013, Professor Allen Vercoe co-founded New Biota, a research spin-off company. And finally, our patient, Anita, was diagnosed with stage 4 colorectal cancer at 41. And after learning more about her disease, was determined to advocate for others, which she does tirelessly. She's the founder of Washington Colon Cancer Stars and has received numerous national awards for her work. Together, Rob, Emma, and Anita will share with us cutting-edge approaches to altering the gut microbiome.
So welcome everybody to Work Package 6. And today we have with us Drs. Allen Vercoe and Dr. Robert Holt, who are taking 2 different approaches in the Canadian labs to the microbiome and colorectal cancer. One is a predatory bacteria approach, which we will term as the offensive side to it. And on the defensive side, we have our cancer vaccines. So we're going to talk with first, we're going to talk with Dr. Vercoe about the predatory bacterias. So welcome, Dr. Vercoe. Could you tell us a little bit about how bacteria plays a role in the microbiome?
Sure. Well, the microbiome that we're particularly talking about, of course, is the colonic microbiome, so the microbes that live in the colon. And there are many, many different types of microbes that live in the colon, but the vast majority of them are bacteria. And in terms of colorectal cancer, we know that there are some bad actors, if you like, that seem to pop up more often than others in terms of association with tumors, and in some cases we know that there might be some impact of those microbes in actually tumorigenesis, so the actual start of making tumors and then potentiating them, so them continuing. And so bacteria in the microbiome can be thought of as good or bad, or sometimes both. It depends on the context.
That's very interesting. And when we talk about predators to these bacteria, what do we mean by predators?
Yeah,
so actually Pac-Man. They
actually Pac-Man. Well, they don't look too much like Pac-Man. They are very, very tiny bacteria. And what these microbes do, they have a very peculiar lifestyle, which means that they are what we call obligate parasites, or obligate predators, I should say, which basically means that they can only live by eating other microbes. And so you can't grow them on plates like you can in a regular laboratory environment. You have to feed them with microbes in order for them to grow. So what they do is they swim very, very fast up to their target bacteria, and fast enough that they can kind of almost poke a hole into that bacteria once they kind of make contact with it. And then they get inside that microbe, they seal up the hole that they've left, that they use to get in. Behind them, and then when they're inside that cell, they basically suck out the contents of the cell and eat it. After which time, and they've filled their bellies, they basically pop the target cell open, and out comes lots of cells, because they've multiplied whilst they've been inside the cell, and then the life cycle starts again. And so it's a very peculiar but really interesting way that these microbes live. And in the context of colorectal cancer, we think this could be of real benefit because these microbes can attack particular cells of the microbiome, which we know have connotations with colorectal cancer. We call these oncomicrobes. And by doing so, they can leave the beneficial microbes alone and potentially take out the more dangerous microbes and reduce the burden for the patient of these microbes, these oncomicrobes that could be causing damage.
I have to say the end result is great, and the idea is how to attack colorectal cancer, perhaps even prevent it. But I have to say it does sound a lot like one of those alien movies that I saw years ago. And so it does, it's ringing bells all over the place here.
Yes.
I want to turn now, if I might, to Dr. Holt for a bit to understand what the defensive side looks like when we talk about vaccines and how they work. What's the goal of having a vaccine in terms of, is it preventative or is it therapeutic for colorectal cancer?
Yeah, the aim is to prevent colon cancer if possible, but more generally, it's to protect patients against the actions of the bad actors. So we're getting a good view of what the bad actors are now. We've got some candidate or suspect bad actors identified. So the main one that we're focusing on is Fusobacterium nucleatum, because it's very strongly associated with colon cancer. So it infects tumors in a lot of colon cancer patients, especially as the cancer gets more advanced to the later stages. So really the question is, can depletion or protection from Fusobacterium in more advanced cancer settings be beneficial? Can it extend patient survival? And the way we want to try to do that is by using a vaccine as an adjuvant to conventional therapy. So there isn't really the notion that just providing a vaccine that targets this bacterium will deplete it and cure the cancer directly, shrink tumors. That's unlikely. That doesn't tend to happen in vaccine settings in cancer. So rather, it's used in addition to standard therapy. So if you can remove through surgery and chemotherapy the bulk of the tumor and the patients are in remission, then can you prevent reinfection? Because Fusobacterium is very prevalent and you're very likely to be re-exposed. So can you prevent reinfection in that setting and extend remission and extend survival and quality of life for the patients?
So that's interesting. So being a patient advisor on this work package together with Anita Isler, we're going to come to in a minute, I have to say I never thought of it in that way in terms of adjuvant therapy or preventative therapy following surgery when you debulked or removed your tumor in the first place. But the platform that you're using on is an mRNA vaccine. Can you tell us a little bit about that?
Yeah, so it's really leveraging the mRNA lipid nanoparticle vaccine platform, that technology that's proven so effective against COVID-19. So it enables really a rapid development cycle where you can test different candidate vaccines very quickly because you can manufacture them in the lab quickly. And the safety profile has been well proven and its efficacy. So it's a fantastic way to deliver vaccine antigens, which just means the part of the infectious agent that you want the immune system to recognize. It allows delivery of those antigens very effectively in so many people now.
And now, is it coincidental that that we have the offensive and the defensive packages working in the same work package? Is it a 1-2 punch? Do we start with the predatory balos on the bacterium and then follow up with a vaccine, or are they two individual types of treatments or potential treatments?
Well, these are experimental approaches still, right? So for vaccines in particular, and for Fusobacterium nucleatum in particular, it's associated, the infectious agent it's associated with colorectal cancer, and it's associated with treatment resistance and worse outcomes for that type of cancer and other cancers. But that doesn't actually tell us that it's causing those undesirable outcomes and worse disease, right? So it could be that whatever features of the cancer are leading to worse outcomes and recurrence and metastatic disease are features that Fusobacterium finds appealing and also likes the cancer setting for that same reason. So really, these are experimental tools to try and dissect that relationship. So if we can deplete Fusobacterium and keep it from coming back by predatory bacteria, by vaccines, does that actually lead to better outcomes? So initially, this is experimental. It's a research project, but if it turns out that that's the case, then yes, we'd like to move towards more direct clinical testing.
As a non-scientific person, it seems like this makes so much sense. It's so interesting. And I can't wait to see what's going to happen with your further research, because I think you're on the right track, and how the chemotherapy and everything changes people's systems too.
You took the words out of my mouth. You took the words out of my mouth, Anita. Why don't you tell us a little bit about your story?
I was diagnosed at 41 with stage 4 disease. I didn't know my family history correctly. I thought my dad had bone cancer, but come to find out it was colon cancer that had spread to his bone. I didn't grow up with my dad. He lived in a different town, and so no one really talked about it back then. So I should have had screening in my 30s because my dad died in his mid 40s. So my case could have been preventable. But I went to, my primary care doctor and was misdiagnosed because I was too young. I didn't need a colonoscopy. So anyway, I was diagnosed 4 months later with 7 tumors in my liver, and I went through a resection and had, 1.5 foot of my colon taken out and an ovary that looked bad and a bunch of lymph nodes. And then I started chemotherapy. I was told that I would never be like just a resectable candidate because they were never low, but the hope was to do a combination. And so I was lucky, and I haven't had a recurrence. And I became an advocate because my story was preventable. And also the younger people, I was seeing it happening in my friend group. I had lost a friend at 37 to colon cancer 7 years before. So to realize how often this was happening to younger people and that they were misdiagnosed, I felt like I had to do something to change that scenario.
And you've done such an amazing job. And as you know, in Canada, we also celebrate Dress in Blue Day, which you invented in the United States. And so it's great working together as 2 patient advocates on this work package. So what does it mean to you to actually participate in this isn't clinical research, this is really basic research. And why should other patients, do you think, be involved in this type of work?
When you're in the cancer world, all of a sudden you have a new vocabulary. Well, for researchers, like when I first joined this grant, I didn't know half of the things they were talking about. I still don't know everything they're talking about all the time, but it's giving me well, I have a much greater respect for the time and everyone's expertise, and they're just as passionate about their part as I am about awareness and education and getting people, the best of care. Like you said, we balance you guys out because we're here reminding you of the patients that need your help. You also balance us because, we see all the despair all the time and all of friends we lose. So I think it's very valuable. And I also feel like this is an amazing team that never makes you feel silly if you ask a question that may, not be scientific, or maybe you've already answered it. I just think that we have a very lovely group of people.
How has it impacted you?
Well, I think it's impacted us in a really positive way, from the point of view that when we are scientists in a lab, we tend to get sort of a bit sidetracked, if you like, into thinking about the science, and we forget sometimes that what we're working towards. And so having patient advocates so deeply involved in the research that we're doing provides us with a kind of compass, if you like, to point us in the right direction of which to go, so that we're always aligned with the goals of the funding agency and of the advocates to what is the ultimate goal of what we're trying to do. And if we keep that in mind, then we'll stay on the right track, and we won't get kind of sidetracked into to doing things which are scientifically interesting but probably not as helpful for patients. And so I think that's probably what I would say is the most important part for me.
Yeah, I think I speak on behalf of our whole group in that it's been extremely valuable. And one example of that is in our discussions at the lab meetings, we tend to drill down to the easier questions. And what I mean by that is we take a more and more reductionist approach and minimize the question to something that's maybe answerable given the data that we're collecting, but is at the same time likely only a very small incremental gain in the bigger battle here. So one thing that's super helpful is when you ask questions about, well, what's the impact of that incremental gain in the larger picture? Is that likely to actually make a difference? Is it, you know, is there anything fundamentally problematic with your approach reaching clinical testing and ultimately to make a difference to patients? So we need to keep the bigger pictures in mind, and it's not instinctive. We tend to be reductionists, so it's very helpful in that regard.
I would love to thank all of you for participating in today's webinar as part of the overall OPTIMISTICC program. Thank you so much.
Thank you.
Thanks, Anita, and thanks, Barry.
Thanks.
Terrific. Thank you again to Rob, Emma, and Anita for sharing not just novel and cutting-edge approaches that could potentially prevent cancer from happening, but there was a wonderful quote here that I wanted to share. Patient involvement in OPTIMISTICC research helps them to cultivate hope for the future of care. And for researchers, it helps them to stay focused on the ultimate goal of their research, improving outcomes and quality of life for patients. Patients as the compass for research. Another reinforcement of the message and the theme that we've been intending to drive through this webinar.